Hi Ed, this is a demo for Milestone 1 for JSON Yay. On this window, it's a batch file for converting the FBX files to the archive file, which has an extension of .bin. The converter has two optional switch. There's a -n and also -t. The -n is for specifying the name of the mesh that will be exported, and this is necessary if the FBX file has more than one mesh, which is the case for the MISO. And the -t is for specifying the TGA file, and it can be used multiple times, like for the wallbear, and then you will take those two files and put those into the archive file. And we're going to run that right here. It's going to print out the vertices and the triangles. I did that on purpose just to show it is doing something. Here you can see the archive file is being generated as we are speaking. Okay, now we can look at the code. I put all the files into one project or one solution file. I think that's easier because the reader and the writer can be shared between the viewer and the converter. And I also have a unit test for reading and writing the archive file as well. And in the converter, most of the work being done are in the FBX export class. It is a singleton class that will hold the vertices and also the triangle list. And that's being done using the STL vectors. And the way the vertices and triangles are exported are pretty much the same thing as we did in the class, except I remove a lot of unnecessary functions and a lot of unnecessary code that we don't use, so that all the FBX code are in this file, and it's only 300 or so lines, actually 400 or so lines. The way the FBX export is used is basically from the main file. In the main file, checks the arguments, make sure it has more than enough arguments, and does the parsing here. Is a -n for the name of the mesh, and the -t for the texture files. And the FBX and the bin file has to be the last two arguments passed into the converter. And once the command line arguments are parsed, it calls the static function of FBX exporter with the input name and the mesh name. Here's the main interface function called from the main, and it basically gets a singleton instance of the exporter, sets the mesh name, sets the output name, and then it initializes the SDK. This code is basically taken from the import scene. And here it is, the initialized SDK. And once that's done, cause the load scene in the export scene. The load scene is also basically taken from the import scene as well. And export scene is it's where we actually does the exporting. I took out a lot of they will traverse through the code, through the nodes, and export node. Export node is basically just a switch statement, and since we are only getting the vertices and the triangles, but I only try to look for the mesh and then remove everything else. It also checks for the mesh name, make sure it matches. And once it does, it will call the export mesh. And the export mesh gets the control points and export the polygon and also the textures. That's some debugger information that I will remove after the video, after recording. Since the textures can be embedded in the FBX files, I give the computer an option of specifying an external texture. Because if the texture within the FBX is an absolute path, most likely it will fail because the path is different. And once this is exported, once we got all the vertices and the triangles, it will call the main function. Will try to call the write binary file, writing file. The format of the output file has a headers and then followed by the binary data of the file. The header looks like, so here's the definition for the header. The header has a 20 character for the name. That's not really being used, but I just kept that in there. And it also has a bounding sphere, the vector, and also the radius. And it contains a number of the chunk. Each chunk can be like a vertex or a triangle list and a texture. The keep chunks of that, and then they use the zero size array for holding the chunks information. And the chunk information consists of the type. It can be either a vertex, triangle, or texture, and contains the size of this chunk and also the offset of the chunk. So when we are reading the chunk, you can just go to the offset and then start reading directly. So going back to the writing file, after it gets the header, after it makes the header, the way it makes the header is so it will count the number of the plus 2 since